Absolutely. Thanks, Tom. Never get sick of being at Tech Field Day, Networking Field Day, Mobility Field Day. I think I've been at a Cloud Field Day, somewhere in there. So great to be with you, delegates. Thanks for your time. Appreciate it. Everyone who's watching, great to meet you. I'm going to do a quick introduction to Nile for those of you who might not have seen our previous presentations. I'm going to introduce our presenters, the agenda for the first hour. We have some additional content reserved for future time, so we're going to dive into that in the second hour. But in the first hour, we wanted to show you how we do what we do from maybe kind of give you a glimpse into how we are different from anybody else in the networking space. Hopefully that comes through in the first demo that one of my colleagues is going to join us for. And as I mentioned, Suresh, founder of Nile, is going to join us for some of his content. But let's get started. Let me tell you what we prepared for the first hour. Introduction to Nile. We're going to dive into this maybe a bit of a high-level conversation on what does it take to build networks going forward. We call it the next-gen network. I want to show you what that looks like, what do we think it should look like. Then we're going to dive a little bit deeper into what Nile Access Service is. Essentially, that's our wired and wireless networking solution. We believe it's pretty unique. Hope you agree. And then to showcase one very critical capability out of many, we're going to dive into that live demo that I mentioned. And hopefully we have a lot of interactive Q&A so that we can get things interesting. So our speakers, Suresh, co-founder, Chief Product Officer. He will lead a good chunk of the discussions. My background is in the enterprise networking space for the last 20 plus years. Aruba, after that Salona, private 5G startup, and for the last year or so at Nile. Shiv, Mera will be running our first demo. Karthik and Dipin will be joining us in the second hour for a closed session and deeper dive into some of the demos there. So right off the bat, I want to highlight what we do and why we think we're different. For the last 20 plus years, we've seen a lot of innovation in the wired and wireless networking space. That's where we play today. We have aspirations to do more in the enterprise networking space, but today it's a wireless and wired connectivity solution. For the last 20 plus years, we've seen a lot of product-centric innovation. Every single problem that we found, discovered, whether it comes to wired security, wireless coverage, integrated deployment management, we always threw a new product at it. That's generally has been the motto of innovation. In the early days, wired LAN, of course, connecting desktop computers and voice over IP phones. And then shortly after that, it was wireless LAN making its way to enterprise environments, controller-based design and deployment. Soon enough, we said, hey, the number of connectivity needs in the enterprise is growing tremendously. Why don't we just manage everything from the cloud? Start doing that, start playing around with cloud management, cloud monitoring, orchestration, cloud activation. And recently, we have started looking at all these dashboards and reports this infrastructure is creating, and we said, we don't have all the time in the world to look at all these reports. Why don't we just start generating summaries, a summarized task list, if you will, by just using AI to give us some structure. Every step of the way, there was a little bit of incremental innovation. And Nile started in 2018, and we said, well, given at our disposal past learnings from successful companies, and given where the technology stack is now, with cloud native software development as a service delivery of practically everything that we experience in our daily lives and our work lives, arrival of zero trust security, arrival of AI, not just to summarize reports and dashboards, but actually to automate tasks. Can we create something new? Can we create a service where we treat the service as a product and product as a service and guarantee performance for coverage, availability, and capacity? And so far, it's been going well. For the last 12 months, we've been in the market and pretty good growth, 10 million square feet covered and 90% year-on-year growth. And primarily, we've been active in the carpeted office spaces, higher ed, primary education, and growing number of warehouses. So that's kind of what we do. And again, Suresh will dive into a lot more deeper as to how we do what we do, but just wanted to give you a perspective. Before I hand it over to him, The picture today in the enterprise networking space, I'm quite familiar with this because I come from this industry. For those of you who dealt with wired and wireless network design, troubleshooting, installation, ongoing maintenance, ongoing management, you can probably relate to it. This incremental product innovation, hey, solved lots of challenges, right? I'm the first one to admit because I was there when we were rolling out hundreds of AP deployments at campuses and higher education institutions, etc. But at some point, things started to get a little bit more complex, right? If you look at an enterprise networking portfolio, you will see probably multi-generation of products, each running their own software stack, each software stack requiring a different configuration or best practices guide. If you try to stitch together multi-generation products into an existing building, existing facility, you probably need some more instructions. And maintaining all the hardware from APs, switching, sensors, requires actually additional appliances, software stack from network access control, controllers for the DMZs or to centralize wireless LAN traffic, of course, DHCP infrastructure, profilers, which allow us to identify different types of devices, IoT infrastructure, so that we can apply security policies on them. So when you get started for the first time, when you walk into a building, you're like, yeah, this doesn't sound like too big of a challenge to deploy wired and wireless here. But by the time you look at all the operating systems, all the models and the product lines, you kind of can't help yourself but notice the inherent complexity around it, right? And this is just the hardware. Ongoing software and maintenance requires some support contracts. If you don't have the IT staff in your team, you might want to sign up to consulting and professional services from your favorite channel partner or from your favorite vendor. And then if you don't have the capital budget to actually purchase the gear and install it and start managing yourself, you might want to sign up for a network as a service offer. Maybe you even go to a managed service provider. We think that these 10 plus steps between innovation to realization of that innovation, again, it's a bit too much. We want to shrink that further, and hopefully our demonstrations today will show you how we can help do that. So that's my quick introduction about what we do, how we approach the problem, but Suresh will tell us a bit more. Here goes.
We're going to share our thoughts, our insights into how we went about building the solution and our approach. But primarily, we are here to hear your feedback, your insights, and continue to improve our service and our approach. With that, I'm Suresh Katakam. I'm one of the co-founders and chief product officer at Nile. Prior to this, I was at AWS, focusing on large-scale AI, ML use cases and partnerships. Before that, I was in networking industry for almost 25 years. Built a lot of the technologies that we're talking about here and co-authored some of the industry standards and published several research papers in AI. And I have more than 40 patents in networking industry. With that, I laid out all the challenges in the networking industry today. And how is the networking industry responding to these challenges? So recently I was at an EBC with a customer, large global company CIO. Before I started the presentation, the CEO said, Suresh, I've heard the same thing over and over for the last 30 years, but in a more convincing way. Why was the customer so skeptic before starting the presentation? And the reason they were skeptic is, look at how the industry is responding to all the challenges. More screens, more fancy graphs, and more AI washing or more marketing messaging. It's the same thing that we've been doing again and again. We have not fundamentally changed the underlying hardware, software, the complexity associated with the networks. Instead, we kept on adding more and more products, as I said, and more features we released it. And because of that, even today, after almost 20, 25 years later, we still have the VLANs, we still have the configuration problems. Isn't it about time? We expect a lot more from the networks. As you guys know, I co-authored some of the industry standards as well. But when we wrote the standards, if you go to IETF, when you look at the standards, we focused really on the control plane and data plane. How do you get connected to the network? How fast can you forward the packet? How well you can forward the packet? Security was never considered as part of these standards. Security was always an afterthought. Second is, you heard of the observability for cloud applications, where you have deep instrumentation, understand itself so that it can monitor itself. Isn't it about time networks also have the same capability so that it can monitor itself 24/7. And then, as you know, networks can go into universities, can go into warehouses, hospitals, and corporate office spaces. All these environments are different. Shouldn't the networks adapt themselves? We talk about autonomous cars. They adapt themselves to the changing environments. Shouldn't the networks adapt themselves? Isn't it about time? Frankly, then networks should just work. Any thoughts, questions, comments? So we saw the problems, we saw how the industry is responding to all these challenges, and we said, let's go back to the clean sheet of paper. And we talked to hundreds of customers, partners, and analysts, and said, what should be the next gen wired and wireless? More products, more features, more fancy screens? Or is it all about delivering the outcomes? Yes, there are lots of technologies, AI, ML, and all of that. But is it about technologies or is it about outcomes? And what we found from these customers, it's been 30 years, networking industry has been existing. And customers said, it is about time the networks guarantee the performance, especially when it comes to wired and wireless. The availability, of course, it's expected to have it, coverage and capacity everywhere inside your building. The customers want, it's about time the networks deliver the guaranteed performance. Then second is, you guys know, lately for last 5-7 years, zero trust has been there, right? And zero trust is being used for users to access the applications. But today, when you have users at the campus and user to user, IoT device to IoT devices, who is going to provide the security? What about the underlying physical network security? What about the network layer security? What about every user device getting onto the network? What about the applications and the communication between the users? How are you going to stop propagating malware within the lateral movement of the malware within the networks? Shouldn't the customers told us it needs to come built in? And third is, after all said and done, we can talk about how much AI is helping us to reduce the networking tickets, but more importantly, the operational challenges still remain same. For every dollar customers spend on the CapEx, they're spending $3 to $5 on the OpEx over a period of 3 to 5 years. Depending on the customer environment, it changes. And the reason is the network design, network architecture, bill of material, the deployment, day 2, P-certs, end of life, end of support, software upgrades, maintenance, configuration, backing up the configuration, and restoring the configuration, optimization. All of these are not gone away. No matter how many, whether we use microservices, whether you use AI, none of this is gone away. Customers told us it's time to eliminate these, or if you can't eliminate it, simplify some of those operations and handle all of these operations for us. Then the fourth one, as you guys know, whole industry moved to like whether it's software, whether infrastructure is being consumed as a service. And customers want to continue to pay as a subscription basis. But there is a challenge. In the last 1-2 years, you probably heard the subscription model is increasing our OpEx cost and it's growing out of proportion. Everyone is not happy with the subscription model. So they said, especially with the hybrid workforce that's happening, everything is in flux. Customers do not know the capacity that they need to build for the networks because the number of employees that are coming onto the network, they do not know it. So they want the subscription model, consumption model, at the same time, a flat model, so that the costs are not going to keep going up and up. So these are the requirements we heard, and these are the outcomes the next-gen wired and wireless network should deliver. With that, so we said, how do we really go about it, frankly? And we looked at the car industry. Right? We had all this infrastructure in the car industry, and how are they delivering autonomous cars? So before that, I thought, I drive 2011 Prius, and I thought I'll take the car, and I was working with my son and trying to put it all together and see, can I develop an autonomous car using the existing infrastructure or existing car? And look at the number of things I have to buy so that I can monitor the road, the sensors that I need. And look at how the car turns out to be. It's a Frankenstein. It's complex. Underlying problems have not gone away. And at the same time, I could not accomplish the full autonomous car with that. What is the networking industry is doing? It is taking the existing hardware and software that's been built over the last 20, 30 years and trying to build AI on top of it or automation on top of it. And you can only go so far. And how did the car companies respond to this challenge? They built a brand new car platform, simplified, eliminated the complexity. They added lots of sensors. And as you guys know, the cars, even in the past, engine check or tire pressure check, but now with autonomous cars, they need to know every aspect of the car. They added a lot of instrumentation so that they know every aspect of the car, but also added lots of sensors to monitor the environment. anything, everything that's happening around the car. And this is what they needed. And so a lot of data was needed for them to really build autopilot software on top of that. So in the first session, we're going to talk about how we build the underlying hardware and the software. And in the second section, we're going to be talking about the autopilot software, how we built on top of that hardware platform we built. So based on this, car companies have learned, but networking industry hasn't learned how to build the autonomous cars or autonomous networks. And I'll quickly go back onto this. So just because I take and put all these sensors and put marketing message and call self-driving car, it's not going to make self-driving car just because I put the tag there, right? So what did we do? Just like cars, we said, first thing what you need is the core, what we call network elements, the APs, the switches, the sensors, and everything, anything that considered as part of the network. That's a core. That needs to know anything and everything about itself, CPU, memory, processes, and the status of every process, the buffers, the queues. You might be aware of OCP, Open Compute Project, and this is driven by cloud companies. And Facebook was specifically driving a standard called SAI, Switch Abstraction Layer. This is the ASIC, because when you're deploying large-scale number of systems in the data centers, they wanted to know every register that's happening in the ASIC, status of every register, so that the data is coming in the cloud and they can manipulate the switch to provide the better performance. Or if there are any faults, they can correct it. That's a level of deep instrumentation you need it if you want to deliver autonomous networks. And second is, just like cars, you need to monitor the environment. Every environment is different. So you need lots of sensors, physical sensors, virtual sensors, software sensors that monitor the RF, the cable voltage fluctuations, power fluctuations, UPS fluctuations, and as well as cable twists, all sorts of problems that happen around the networking. You need to be aware of it, you need to sense it, you need to monitor it, and you need to send the data to the cloud. And third is context. You're serving the users, devices, and applications. You need to look at how are they performing, how is their experience, not just from the networking perspective, frankly, from the end user perspective. You need to get all the context information of every minute of every user and device. And that data needs to come in. Only then you know the entire aspect of the network, core, the environment, and the context. So this is what we felt is the foundational requirement in order to build the next gen wired and wireless. Then second is, another major requirement in order to build this is, you heard of shift left in building the cloud applications. What does it mean? In the shift left means all the testing, performance, and the quality considerations have to be done well before you start developing the software. You start moving all your day two or later on problems even well before you start building the product. Similarly, when you think of the network, and you guys know very well, when we build the standards, when we build the products, I was part of it too, brought many of those products to the market. We kept on building the technologies, the features, the protocols, the access points, the switches, with little to no regard. What does it take to design the network? What does it take to build the bill of material? What does it take to deploy it? What does it take to monitor it, manage it? We did not pay attention to that. We kept on adding more and more protocols and knobs to the technology. But we said, if you're delivering this guaranteed outcomes, you need to take all these operational challenges in designing your hardware and software. Let me give you some examples. And we have lots of demos that will show you all the automation that we have done. But let me give you an example of, when you think of a network element, whether it's access point or switch, you have to first configure the system itself. And second, then you have to configure the ports. Then third is you have to configure the protocols. Then you have to configure all the different knobs associated with it. We have taken all of those and moved into our hardware and software design such a way that we eliminated any reason for you to configure the network level, switches or the APs or the radios or the protocols. And we'll give you a lot more examples as we go through the demos. But when you think of the software upgrades, when you think of end of life, end of support, all of those aspects we considered as part of the hardware and software so that we eliminated all of those challenges, because you cannot take existing system and push it into the operations. So one of the things we tell our engineers, anytime you design a component, software component, you have to make sure the software comes up on its own. There's no engineer or a person bringing up that software, the hardware, the AP, or the switch. It needs to monitor and manage itself. You cannot send an alert to somebody saying that someone is going to take a look at it. So you need to write the system such a way that ideally you eliminate the problem. You don't need the component. If you do need it, you need to make sure that it can monitor, manage itself. That's what we believe.
So
we need to build it. Yes.
is there hardware on premise? So do you have switches? I mean, it seems like you would have to.
Yes.
So they're manufactured by Nile?
By Nile. So we built entirely. So we're going to go into more details on the stack that we built. But yes, it is our own hardware, our own software, because that's the only way we can guarantee the service. That's the only way you can guarantee that network is up and running. You can manipulate, manage, and do the closed loop automation.
And is it for campus as well as data center, or is it campus?
Campus only. So campus branch.
Will it be data center?
So at this point, no, the answer is no. We are looking at really taking the user to all the way to the application running in the cloud or in the data center or on the internet, but we're not considering any of the data center part of it.
So will there be like an SD-WAN component to tie this together, or just focus strictly on-prem?
So today,
LAN?
so I was just talking to him earlier. We are starting with the wired and wireless LAN, but our goal is to really connect. When you think of a hospital, they're in the business of patient care. They're not in the business of knowing SD-WAN, wired, wireless, controller, controllerless. So our goal is to give you high performance, low latency, secured connectivity from your device all the way to the application running in the cloud. So we're in the first phase of the company where we're providing wired and wireless. Okay. Then we continue to grow towards the north.
Okay.
A lot of the big networking companies now are focused on being able to provide the same managing interface, same visibility for both campus and data center. So what is your solution for that, since you don't have data center?
What if we can take over the entire campus out of it, where you don't have to manage it, monitor it? We give you the visibility and control, but you don't have to manage it, monitor. So one less thing to be concerned about, so that you can focus on your data center. Our approach is really take away all the complexity, all the problems associated with the campus side of it, so that you can focus on the data center.
And you referred to this kind of in comparison to a self-driving car, the autonomous self-driving car. So is this at the point of being a self-healing network yet?
Sure. So actually, I don't like the word self-healing, I'll be honest. Healing happens once you have a problem. That's a healing. We want to eliminate the problem to happen. So we do not wait for the problem to happen and then heal. So the idea is, when I was talking about car, once you get into an accident, there's no point trying to fix it. So the idea is to have the deep instrumentation, have the sensors, have this data coming in, and also build the hardware software such a way that it's extremely simple. We'll go into more details, extremely simple, but can go into all sorts of use cases. And the data is coming in real time. You can predict the challenges in the environment and continuously adapt yourself to the changing environment.
And does the notification go to your customer? And if so, what means is used for that notification? Or is this as a service something that Nile takes care of if there's an adjustment that needs to be made?
So we take care of it. It's delivered as a service. But some of our customers asked for, hey, can we get the visibility into how are you handling it? So we do provide the visibility, but they don't need to really handle any aspects of it. If they're interested, they can subscribe and they'll get the information. Otherwise, we handle all of the networking related issues.
Thank you.
So this telemetry data in all the health of the environment, is this stored on-prem, or is this stored up in a cloud somewhere?
It's stored in the cloud.
Okay.
The systems, the users, devices, the environment, everything is coming in real time to the cloud, and the cloud is constantly analyzing it and fine-tuning it.
So if I have an issue on the WAN, it says cuts off my connectivity to the cloud, is there a window that I have with that telemetry before it's lost, or
sure,
how does that work?
So there are a couple of things. So first of all, our network will continue to function even in the absence of the internet or the cloud down. And second is, there's a built-in resiliency within the network. So even if I'm lost, if the connection is lost, and there's a change that happened, the network reacts locally. The fine-tuning is the part that's where the cloud is needed. Now, going back to, we have the buffering mechanisms within our systems, and they can save for hours and hours that information. And we also have a capability to aggregate. Like if your internet is down for 2 days, there's only so much buffering. So we aggregate the information, and we have smart mechanisms so that we focus on things that changed. Things that did not change probably don't have to come when you do not have the buffering capacity. Okay. So we can buffer it and send it when the network or the internet comes back up.
Okay, thanks.